Lesson 5-4, Simplifying Fractions and Ratios. In this lesson, you learn to express fractions and ratios in simplest form. When are you ever going to use this? Knowing how to write fractions and ratios in simplest form can help you analyze baseball statistics. Words that we need to learn: ratio, equivalent fractions, and simplest form. Let's take a look at this example. A roll of candy contains 16 candies. Tyra has a roll of which 4 of the 16 candies are pink. You can compare the number of pink candies to the total number of candies using a ratio. Okay, so let's define what a ratio is. Write this down in your notebook. A ratio is a comparison of two numbers by division. The ratio that compares 4 to 16 can be written in several ways. So this should be in your notebook. Comparison of two numbers by division. So you know right away that when you're talking about a ratio, the operation of division comes into play. So 4 to 16 can be written in several ways, and these are the several ways. Okay, you can do 4 to 16, 4 out of 16, 4 colon 16. There's another way of writing a ratio, which is a fraction, 4 over 16. So that is another way of writing a ratio, okay? Which is explained here. Ratios can be expressed as fraction. The fraction is 4 over 16. So another way of writing it will be as a fraction of 4 over 16, okay? So fractions that name a ratio, okay, are called equivalent fractions. So when you talk about fractions fractions that name the same number are called equivalent fractions. You have 4 over 16, 2 over 8, and 1/4. They are all the same fractions. Okay, so they are considered to be equivalent fractions. Okay, so fractions that have the same that are the same number are called equivalent fractions. 4 over 16, 2 over 8, and 1/4, okay, are all equivalent fractions. Let's see how they're equivalent. Let's use a model to see how they are equivalent. Okay, because if I look at 1/4, this is how 1/4 would look like. Okay, and this is how 2/8 would look like. If you notice, the size of this rectangle is the size of that rectangle compared to the same rectangle. Okay, and that's the reason why they are equivalent. Okay, and that goes with the same as for 4 over 16. Okay, so the reason why they're equivalent is that if you notice on the model, they have the rectangles have the same size. Okay, so 1/4 is just another name for 2 over 8 or vice versa, and that's the reason why they're called equivalent fractions. Okay, so the rectangles are the same size and the same part of fraction for each rectangle is shaded, so the fractions are equivalent. That is 1/4 is equal to 2 over 8. And let's use pencil and paper to figure out method number 2, how they become equivalent. Now if you notice, to be able to get 2 from 1 to 2, you multiply 1 by 2, and therefore you need to multiply 4 by 2 as well. Okay, and in the same manner, from 2/8 is equivalent to 1/4. To be able to from 2 to get to 1, you divide 2 by 2 to get to 1, and then you divide 8 by 2 to get to 4. Okay, multiply and divide the numerator and the denominator of the fraction by the same non-zero number. Okay, will make them equivalent fractions. Okay, let's take a look at a few examples and let's see how this is done. Replace the square with a number so that the fractions are equivalent. So if you notice, 3/8 is equal to square 24. So since 8 times 3 equals 24, multiply the numerator and denominator by 3. So basically you multiply that by 3 because you multiplied 8 to get to 24. So it would be 3/8 is equal to 9 over 24 because 3 times 3 will give you 9. Okay, in the same manner, in example number 2, 15 over 25 is equal to 3 over the square. We don't know what the square is. Since 15 divided by 3 is equal to 5, divide the numerator and the denominator by 5. Divide that by 5. Okay, you end up with 3. Okay, and you end up with 5. 25 divided by 5. Okay, so the equivalent fraction is 3 over 5. Okay, the next definition would be probably one of the more important definitions you need to write down because it will carry on with you until you go to high school. A fraction is in simplest form when the GCF of the numerator and the denominator is 1. To find the fraction in simplest form, find the GCF of the numerator and the denominator, and divide the numerator and the denominator by the GCF. Okay, so let's take a look at example number 3. It uses listing to find the GCF. I will show you how to use prime factorization to find the simplest form of 4 over 10. So let's start. Factors of 4, 1, 2, and 4. Factors of 10, 1, 2, 5, and 10. So if you notice, the greatest common factor would be 2. Therefore, we divide 4 by 2. Okay. You get now 4/10, divide 4 by 2, divide 10 by 2, end up with 2 over 5. So since the GCF of 2 and 5 is 1, the fraction 2/5 is in simplest form. And as promised, I will show you how to do simplify 4 over 10 using prime factorization. Okay, so we get 4 and 10, get the prime factors of 10. 2 factors of 4 are 2 and 2. Factors of 10 are 2 and 5. So if I have 4/10 as my fraction, okay, the prime factors of 4 are 2 and 2. Prime factors of 5 are 2 and 5. Okay, it's just like circling the GCF. Okay, I circled 2 over 2 because they are common factors, and we know that 2 over 2 is also the same as 1, so I put a 1 there, put a 1 there. Okay, and if you notice, what are the numbers I did not circle? That would be 2 over 5. So the simplest form of 4/10 using prime factorization is 2 over 5. This is the preferred method. I would prefer this than listing because you can forget or miss factors when you start listing them. Okay, let's take a look at the next example. The next example, 18 over 21, and then we will do this by listing and prime factorization as well. Okay, so the factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of 21 are 1, 3, 7, and 21. We want to find the GCF of the numerator and denominator. In this case, the GCF is 3. Okay, so the GCF of 18 and 21 is 3. So we simply divide 18 and 21 by 3. We end up with 6 over 7. Since the GCF of 6 over 7 is 1, the fraction 6/7 is in simplest form. Now let's do this by using prime factorization. Again, by using the drop-down method. Okay, let's find the prime factorization of 21. 2 goes into 18, that's 9. Okay, 3 goes into 9, that's a 3. We stop. For 21, 3 goes into 21, that's a 7. All of them are prime. Okay, so let's write our fraction, 18 over 21. And let's list the prime factors of 18. 2 times 3 times 3. Prime factors of 21, 3 times 7. Okay, so again, I can circle 3 because they're common, or I can just cross it out, put a 1, put a 1. Okay, so I just multiply what's left. 2 times 3 is 6, and 1 times 7 is 7. Actually, this is 2 times 1 times 3, but it doesn't really matter because of the identity property of multiplication. Okay, so 2 times 1 times 3 will still be 6, 1 times 7 will still be 7, and there you have it, 6 over 7, using prime factorization. Okay, now let's do the last example in statistics. Approximately 26 of 100 American households have 2 or more VCRs. You're probably not familiar with VCRs anymore because we are now on DVDs, okay, and Blu-ray players, okay. So approximately 26 out of 100 American households have 2 or more VCRs. That was probably around 2001 or 1997, I would imagine. Express the ratio 26 over 100 in simplest form. Okay, let's do this. Let's list the factors. Not worry about the time period. Okay, factors of 26 are 1, 2, 13, and 26. Factors of 100, 1, 2, 4, 5, 10, 20, 25, 50, and 100. Look at the factors of 100. There are a lot of factors for 100. If you miss one, okay, you might not be able to find the GCF. So the GCF would be 2. Okay, so what we do now is simply divide both sides, divide the numerator and denominator by 2 by the GCF. 26 divided by 2 is 13. 100 divided by 2 is 50. So you get 13 over 50. Let's find out how to do this using prime factorization. 26 and 100. 26 is simply 2 times 13, so we're done with that. Oh, sorry, I forgot to circle my prime factors here. Where are my prime factors here? See, you need to circle your prime factors so you know that they're prime and you stop factoring. Go down there, 26, 2 times 13. 100, give me 2 factors of 100. Let's do 10 times 10. If you notice, the first number does not have to be prime right away. Just get 2 factors of 100 and you'll still end up with the same prime factors. So 10 is not prime. 2 factors of 10 are 2 and 5. Those are both prime. Okay? So the prime factorization of 100 is 2 times 2, 5 times 5. So let me write the fraction 26 over 100. And let me write the prime factors of each. This is 2 times 13. This is 2 times 2 times 5 times 5. Okay? So if you notice, 2 over 2 is 1. So I can simply cancel that one out. Make it a 1. 1 times 13 is 13. 2 times 5 is 50. And there you have it. You get the you get the simplified form, okay, of 26 over 100 using prime factorization. Okay, and that is the end of our lesson, boys and girls. Thank you for watching.